Yo, what's up, guys? Episode 59, baby. Woo! Woo! Let's go, dude. Let's check out our Pokemon sound of the day. Ooh. Got an Arcanine. Arcanine Pokemon. Let's check out the sound. Okay, that is definitely not the sound. Such a good dog. Nice. There's our sound of the day. Man, this hot chocolate's good, man. Let's check out our problem of the day, though. We had a hard problem today. Let's take a read, though. String 1, string 2. Return the shortest string that has both string 1 and string 2 as a subsequence. Kind of thought it was a dynamic programming problem. We're going to skip this one for now. Let's take a look at our Leetcode problems. I'm going to turn down the air conditioning. We need to get a little air in here. Some cold air in here, man. Okay. All right. Let's lock in. Okay. Check out some hash map. Do a hash map problem. Let's check out this one. Turn the total number of subarrays given an array of integers nums and an integer k. Return the total number of subarrays whose sum equals to k. can we approach this problem? Do we generate all the subarrays using recursion and then prefix sum? You know, I'm thinking generating all the subarrays using recursion, but I think there's a better way to do it. Did my video upload yesterday? Okay, yeah, it did. It's got no views though. Let's go. Okay, let's start with the brute force approach, right? I think this should work. I don't know if it'll submit, but we can try. In range length nums. We do, well, J in range length nums. If k is equal to the sum of I and k, I and j, sorry. Count here, count is equal to 0. Sums I is equal to k, and increase k plus equal to 1. Where it's not associated with a value. Oh, whoops, this might be I. Can we do this though? Expected to. Why is this not working here? Well, I think we gotta reset the count after each iteration, maybe. No? Do we? No. No, we don't. Okay. Okay. We need to do prefix sum. That's what I'm doing wrong here. Current sum. K is equal to we want to increase j plus or equal to recursive sum putting an output of 1 here. I think we're missing, we're not counting ourselves, so if nums I is equal to k, sum is equal to 1. Otherwise, else underscore is equal to 0. Alright, we just make this I. There we go. Okay. So why wouldn't this work? I feel like that's the same thing, you know? Let's see if this submits. I'm curious, they allow n squared solutions. Nope, it's too slow. Too slow. Nice. Okay. So now we're going to have to optimize our code. So, okay, so now how can we optimize this? Create a dictionary. Arrange length knobs. I think we have to use prefix sum as well. Using some extra space. Okay, so I'm supposed to equal nubs J. Okay, is equal to cosine p plus equal. Trying to think. So if we had, let's do 1, 2, 3. I feel like that's a better test case. 1, 2, 3. Do the hash map, right? To be honest, I really don't know what the optimal solution here is, how to do this in OLVan with a hash map. I generally don't know. 1, 2. I don't know. I don't know how to optimize it. I really don't know. Man. I don't know what the optimized brute force approach is, dude. I generally don't know. Or prefix sum. A num and num's prefix sum is equal to prefix sum plus num. K and D result. So what are we doing here? We have a array D. We have a prefix sum and a result. So this is our count to return, and we've got the prefix sum. For num and nums, prefix sum is equal to prefix sum plus num. Okay. If prefix sum minus k in D, result is equal to result plus D prefix sum minus k. If prefix sum not in D, D prefix sum is equal to 1. Else D prefix sum is equal to D prefix sum plus 1. Honestly, bro, I started to get super sleepy, man. I take a nap. Jeez. Just ripped ass. I don't know, bro. I don't understand. Bro, I don't understand, dude. Let's watch a video. Subarray sum. $560.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve subarray sum equals k. So simply we are given an array of integers nums, and we are given a target integer k, and we want to return the total number of contiguous subarrays which sum up to the value k. This is our target value. So how many continuous subarrays sum up to 2? Well, we have one subarray with the first 2 elements, and then we have a second subarray with the last 2 elements. That's 2. How many different subarrays sum up to target value 3? Well, we have one subarray from the beginning, and then we have another subarray at the end. Now let's think about the brute force approach first. That's going to be n squared. Why is it going to be n squared? Because we have n squared different subarrays inside of the array. So if we just check every single subarray, right, we start here. Is this sum up to the target k? Nope. Okay, does this sum up to the target k? Yes, it does. Then we check the entire thing. Does this sum up to the target k? Nope, it doesn't. And then we can start over here. Does this sum up to the target? Nope. Does this sum up to the target? Yes. And then we can go here. Does this sum up to the target? No, it does not. And then we're done, right? So we checked every single subarray. That's n squared time. And then your next thought might be, okay, n squared, maybe we can improve that. Maybe we can use 2 pointers. Maybe we can even do a sliding window. So for example, this is our first subarray, right? It's too small, so we add values. This is our next subarray. It's the perfect size. This is our next subarray, and this is too big. So what would we want to do then? Well, maybe we could try, taking the left part and moving it, right? Moving our left pointer here because we want to decrease the size or the total sum of the window. After you read the constraints, you'll know that that's not possible. The reason why is because the values in nums could be negative. So just by adding a value to our subarray, like adding another value, doesn't guarantee we're increasing the size, and removing a value doesn't guarantee that we're decreasing the size because some of the values could be negative. Now, it still is possible to improve the brute force solution into an a linear time solution, and it's not super intuitive, but you can use the brute force solution as some intuition to get to the better solution. So that's kind of what I'm going to try to explain, and then once you know it, the code is actually pretty easy to write. So let's kind of go through that intuition now. So yes, we are going to be using a hash map in this problem where the key value is going to be the prefix sum and the value of the hash map is going to be the count of how many times that particular prefix sum occurs. But let me actually run through why that's going to work for us. So we see that the target value is k, so let's try out the brute force approach. So we're going to first start at this subarray, right? Just one value. Our sum so far is 1. Then we're going to do the first two values. The sum so far is 2. Then we're going to add a third value. Now the sum so far is 3, right? So we found one subarray, right? We can kind of keep track of that. We have one subarray so far. Next, we are going to go to this part, the fourth element, right? Now our sum is 4. And of course, we're going to do the same thing for the remainder, right? This is going to be 5. This is going to be 6, etc. But let's just notice a tiny bit of repeated work we're doing. Next, I'm going to start over here at the second element, right? Brute force it from here. So far we have 1. Now we have 2. We added a second element. And now we added a third element. So yes, now we reached the target, right? This is sum k. So we can add another one to our total, the number of subarrays we found with k, right? The first one was these 3 elements. The next one is these 3 elements. But notice how we computed this entire sum, right? When we're computing these 3 values, we're basically doing a ton of repeated work that we just did, right? So how could we have gotten this 3 sum a little bit quicker, right? These 3 values summed together a little bit quicker. Well, when we were over here, right, when we had iterated through these first 4 elements, we could have just said, okay, take the entire sum minus the first prefix, right? Just the first value minus that. That would have given us 3, right? But if we're trying to compute every single subarray, right, because we know the next go around when we iterate through the loop, we're going to be starting at this value, right? And then eventually we're going to get to a subarray like this. So when we were going through it the first time with this blue portion, we could have gotten this pretty easily as well. We could have just taken the entire sum minus the first 2 values, which is a prefix of the array, right? But that's also brute force, right? We're not doing anything better. All we're doing is still creating every single subarray. So is there some intuition we can use? Can we somehow be a little bit greedier? Notice how when we've gotten this subarray, our sum so far is equal to 4, right? So what we're looking for, in other words, is can we chop off some prefix of this array, of this entire array? Can we chop off a prefix such that we can make this sum match k? The answer is yes, because we can calculate it, right? Our sum is 4, so let's get sum minus k, which is going to be 4 minus 3, which is 1, right? So we know that so far the entire sum is 4. If we can chop off a prefix of 1, we will still have a contiguous subarray, right, that will exactly match k. Now the only question is, does there exist a prefix in this subarray, right? Not in the entire array. Does there exist a prefix in this portion starting at the beginning that we can remove? Because remember, we want a contiguous subarray. Can we chop off a prefix that has an exact value of 1? Well, we can if we maintain a count of it, right? If every time we compute a prefix, if we add it to our hash map and count how many prefixes have a value of 1. And the reason we're counting is because, remember, since we could have possibly negative values, like this could have been a negative one, there could be multiple prefixes that have a prefix of 1. Because, you know, this is one prefix that sums up to 1. This is another prefix that sums up to 1, right? Because we have a negative one in the middle. So that's why we have to count the numbers. But also, one thing, we can't just go on and compute every prefix before we actually start building up our result. We have to do it simultaneously, right? Because if we just compute every single prefix, then when we get, when we're at this point, right, we're trying to get, okay, how many prefixes have just a sum of 1? Well, if we have gotten every single prefix already, then that'll have been added to our hash map. We might end up removing a prefix like this, right? We can't do that. We're not allowed to do that. When we're at this portion, we only want to remove prefixes that are a subarray of this, right? And of course, we don't want to remove the entire array because it's possible our k value could actually be 0, in which case we don't want every, we don't want to take this and say, okay, remove the entire thing. That sums up to 0. And there's one last edge case we have to worry about. So let's say our k is 3, right? Once we've gotten to this point, our sum is 3, right? So we're going to take 3 minus 3, which is equal to 0, right? At this point, we don't have any prefixes with a sum of 0. So what we're going to say is, okay, since no prefix has a sum of 0, right, then we're not going to end up updating our result. But we don't want to do that. So as a base case, what we're going to say is to our prefix sum, we're going to add a 0 value and say that the count is 1. Basically, we're saying there is a prefix, the empty prefix that has a sum of 0. So now let me walk you through the algorithm. It's going to be a linear time algorithm. I'm going to change this to a -1 just to make the problem a little bit more interesting. So we're going to start at the beginning, add every single value that we can to our array on each iteration, add that to the sum, and every time we compute a prefix, after we are done updating our result potentially, that's when we're going to go ahead and add that prefix to the prefix map. So we start at the first value, we get a sum of 1, 1 minus 3 is -2. Does -2 exist in our prefix map? Nope, it does not, so we continue. But before we continue, we're going to take this prefix that we just computed, 1, and add it to our prefix map. So prefix of 1 has a count of 1 so far. Next, we are going to get the next value, so now we have a sum of 0. 0 minus 3 is -3. Do we have a -3 in our prefix map that we can potentially remove from this array that would give us the total sum of the array as being the target? Nope, we do not. So we continue, but before we continue, we see, okay, we computed a prefix of sum 0. So let's increment the count of prefix of sum 0. So this is now going to be a 2. And now we're going to add the third element to our sum. So now we're going to have a sum of +1. So we're going to take 1 minus the k value 3, -2. Does a -2 exist in our prefix map? Nope, it does not. But we can say that, okay, we computed a sum of 1 again, right? So now we can take the prefix sum of 1 and say that there's 2 different prefixes, this one and this one, that sum up to 1. And we're just going to continue. So at the next iteration, now we have a sum of 2. 2 minus k is going to be -1. Do we have a -1 in our prefix? Not just yet. So let's continue. And now we add the fifth element. So now we have a sum of 3, right? So we're going to take 3 minus k, which is also 3, right? And we're going to get 0. Do we have a prefix sum of 0? Finally, we do. So what are we going to do? We're going to take the count, the number of prefixes that we had that summed to 0 and say, okay, there's 2 different ways that we can create a subarray of k. So we're going to take our result, which is initially 0, increment it by 2. But hold on, what did we just do? Let's think about it for a second. We said, okay, the entire sum of this subarray is equal to 3. And we said, okay, 3 minus k is 0. That means we need to remove a 0-sum subarray from this subarray to get us to the target value, right? So one subarray is, okay, if we remove, an empty subarray, right? Why does that work? Because take a look. This is a subarray that sums up to 3, right? That's the obvious one. So that's where our 2 comes from, right? So far we have one of the 2 ways, but let's continue. There's another subarray, this subarray, right, that has a sum of 0. So if we remove this subarray from our original subarray, then we're removing 0 from the subarray, so this sum stays as 0. So this is the second subarray that sums up to 3 that we have found that ends at this position. So great, so our result so far is 2, and don't forget this subarray had a sum of 3, so let's say one prefix has a sum of 3 so far. And next, we're finally at the last iteration of the loop. So now our sum is 4. 4 minus k, which is 3, is going to be positive 1. So how many prefix sums do we have with sum of positive 1? We have 2, so that means we're going to add 2 to our result. Because what we're saying is, ending at this position, how many subarrays could we get that sum up to 3? Well, because the total sum of this is 4, and we know that we have 2 prefix sums that start here that sum up to 1, we can remove 2 different prefixes that will make this equal to 3. We can remove this prefix, right? That's one prefix that sums up to 1. And then when you look at this sums up to the target 3. We can remove another prefix sum. Remember, this also sums up to 1. If we remove this, then we also have a subarray that sums up to 3. So we have 2 different subarrays that end at this position that sum up to the target 3. And once we've done that, we've iterated through the entire array. Once we're done, right? We did an exhaustive approach, so we ended up getting a result of 4. There's 4 different subarrays in this entire thing that can sum up to 3. So obviously it's a linear time solution as well as linear memory, because we're using this
Bro, I still have no idea what it's going
hash
to
map.
like.
But that being said, now we can jump into the code, and the code is pretty easy once you can figure this out. So we are going to have a result variable, which initially is going to be 0. We're also going to maintain the current sum, which is initially going to be 0 as well. And we're also going to have a hash map, let's call it prefix sums, and it's not going to initially be empty. Remember, we have a base case of 0. We have a single prefix sum that sums up to 0, so that's what we're going to say, like, the empty subarray. And then we're going to go through every single value in the input array, add it to the current sum, right? We want to know what the current sum is. And then we want to know what's the difference that we're looking for. The difference is current sum minus k, because we know if we can remove a prefix sum of size diff, then we can find a potential result. And we could have multiple prefix sums that sum up to diff, so we want to take that and add it to the result. So we're going to say result dot add to it whatever prefix dot get sum up to diff. Now, it's possible that this diff does not exist in prefix sums, and in Python you can return a default value of 0 if this diff does not exist in prefix sums. And then after we do that, that's when we want to add to prefix sums the current sum that we just computed. So prefix sums at position diff, or the key value diff, we want to say 1 plus whatever it already is. So let's copy and paste this. Oh, and it's actually not diff. We're computing the current sum, right? That's what our prefix sum is right now, current sum. And this also can be changed to current sum. So with this line, all we're doing is just incrementing the number of prefix sums that have this particular sum value. And believe it or not, this is the entire solution, right? We only have to iterate through the entire array once, maintaining some hash map. And as you can see, the solution is pretty efficient. So I hope that this was helpful. It's not a very easy problem, even though the code is pretty short and easy.
Burger King soda fountain position. Alright, we're going to come back to this. I'm going to take a nap because I'm actually quite tired. I'm going to come back to this solution. We're going to take a look at it. So maybe it'll help my brain like kind of reset. Alright, I'll be back.